Alright, so today we will be beginning with the second chapter of O level in IGCSE Computer Science, which is called Data Transmission, right? So this chapter will cover topics such as packet switching and the different methods of data transmission, also the USB, right? We will also study how that works. Alright, so coming down to the first topic, which is called data packets, right? So data packets are basically just when a file is broken down into small pieces, right? So let's just suppose there is a 10 gigabit file, right, and it is broken down into 10 megabyte pieces. All right, so 1,000 of these pieces will basically make up that 10 gigabit file. All right, so each piece is basically just called a data packet, right? And this is done so that we can increase efficiency, reliability, and speed, right? So one of the use cases and advantages of using data packets is that let's just suppose that we're transferring this 10 gigabit file over a network, all right, and there is an error, right? So an error occurs during the transmission. So rather than sending the whole 10 gigabit file again, all we have to do is send the few data packets that were lost during transmission, right? So rather than sending the whole 10 gigabit file, we just send a few more MBs, right? A few more megabits of files, and that is pretty much it, all right? That covers the loss that occur during transmission. So this is just one of the few advantages of using data packets. All right, so coming down to what a data packet consists of. All right, so the first thing that it consists of is basically called a packet header. All right, so the packet header includes crucial information such as the destination address, the packet number, and the originator's address. This information ensures that the packet reaches the correct destination and can be reassembled in the correct order. Alright, so the packet number is basically there to ensure that the actual file that we were sending is the same as what is received on the other end when it is being reassembled, right? Alright, so coming down to the second thing that a data packet consists of, right? It consists of a payload. All right, so the payload is the actual data that is being transmitted, right? It could be anything from a chunk of a file, a segment of an email, or even a part of a streaming video. All right, and the third thing that a data packet contains is called a trailer, right? So a trailer basically contains all the error checking information, right? This commonly includes a checksum, which we will study later on, and yeah, this is pretty much what a data packet consists of, right? So it consists of three things: the packet header, the payload, and the trailer. All right, so now we are coming down to packet switching. So this is a very important topic, right? However, it is not very difficult, right? So make sure that you understand this process. All right, so packet switching is basically when the data is broken down into packets, right? And then each packet could take a different route to reach its destination depending on the network's current traffic and configuration, right? So a router is basically controlling the route that each packet takes, directing them along the most efficient paths available. As a result, the packets may arrive out of order, right? And let's just suppose that if the packets do arrive out of order, right, once all of the packets have arrived, the receiving device reorders them to reconstruct the original data, right? This method is highly efficient and robust as it allows the network to manage congestion and failures. All right, so this is basically just a simple method that is very commonly used when sending data packets across a network, right? So when you send a video file to your friend, right, this is actually the process that is taking place behind it. So make sure that you memorize this process, right? And once you actually understand it, it's not that difficult to memorize them step by step, right? So make sure that you remember it step by step. All right, so coming down to its advantages. All right, so first of all, what you need to know is that this is basically just a way to optimize the use of network resources, right? So the router is basically trying to optimize the route as much as possible, right? It makes sure that the data packets are taking the quickest routes and the shortest routes so that the file can be transferred as quickly as possible. And another advantage of this is that if a packet is lost or corrupted, only that packet needs to be resent, right? As I was talking about this advantage before as well. And then coming down to a few of its disadvantages, right? This is not a very suitable application for real-time transmissions. For example, If you're talking to a friend, right, you would not want the sentence that you are saying to come in a different order, right, as packets may arrive in a different order when using packet switching. All right, so this is not a very suitable way to conduct real-time transmissions. Alright, so serial transmission is basically when you send data one bit at a time over a single channel, right? It is simple and cost effective, and it is commonly used in long distance communications, right? For instance, over here you can see that USB connections and serial ports are basically an example of serial transmission, right? Next, we will talk about parallel transmission, right? So parallel transmission, on the other hand, is basically when you send multiple bits simultaneously over multiple channels, right? Even though it is faster, it is more expensive and typically used for short distance communications, such as within a computer, right, or inside a printer. Next up, we will study about simplex transmission, right? So simplex transmission is basically a one-way street where data flows in one direction only. All right, it is used in applications such as keyboard input to a computer, where data only needs to flow from the keyboard to the computer, right? So a keyboard will only need to send the data in one direction. It does not need to receive any data. Therefore, this is a very good example of simplex transmission, right? And these types of transmissions are very easy to implement and they're less complex. And even though they are very easy to use, they still have limited functionality due to one-way communication, right? So many different applications will require more than one-way communication, right? They require two-way communication. So simplex transmission cannot be used in those cases. Now coming down to half duplex transmission. Half duplex mode allows data to flow in both directions but not simultaneously, right? Walkie-talkies are a common example where communication alternates between sending and receiving. All right, so this basically is a very good example of half duplex communication. Anywhere where we require two-way communication, half duplex transmission is one of the best examples, right? However, what you need to know is that this will not allow data to be transmitted simultaneously, right? For that, we will have to use full duplex transmission, right? So full duplex transmission enables data to be sent and received at the same time, right? So over here you can see that half duplex does not allow data to be sent simultaneously, right? However, full duplex transmission allows the data to be sent and received simultaneously in both directions, right? Alright, so coming down to the universal serial bus, right? So the universal serial bus is a widely used standard for connecting peripherals to a computer. So if you have a laptop, chances are that it has multiple different ports into which you can connect different types of USBs, right? So USB type A, type C are one of the most commonly used types of USBs, right? And if you have a laptop or a PC, it probably has multiple ports of USBs, right? Anyways, so coming down to a few of its applications, right? So first of all, it is used to transmit data, right? It is one of the widely used applications, right, of a USB. So first of all, what you need to know is that this uses serial communication, right? USB, as the name says, universal serial bus, is basically using serial communication, which means that it is transmitting one bit at a time over a single channel. And then secondly, this will be using packet based transmission. All right, so data will be transmitted in packets. So a few other uses, right? So first of all, it is used as a host peripheral model, right? So this is basically where the host is basically controlling the communication with the connected devices. All right, and then secondly, it is used as plug and play, right? So if you have a mouse, right, and it uses USB, all you have to do is basically plug it into the computer or the laptop, whatever you have, and you can basically just start using it straight away, right? This is one of the very few advantages of using a device that connects using USB, right? All you have to do is just plug it and you can use it straight away almost. Secondly, it is used as a power supply, right? Power supplies basically mean that if you have a mouse or a keyboard, right, it will require some kind of power to actually power its sensors and other kind of stuff, right? So USB also works as a power supply, right? Alright, so coming down to the benefits of the USB interface, right? So first of all, it's universality, right? So as I told you before, this is one of the most widely used interfaces, right? So this means that if you have a device that connects using USB, you can plug it into many different devices. All right. Secondly, it's ease of use, right? So as I told you before as well, all you have to do is plug it, and most probably your laptop will already have the driver for the specific kind of mouse or something installed already, right? Third is its speed, right? So USB is now coming in multiple speeds. Over here you can see that super speed USB is transferring 5 gigabits per second, which is very high. All right. And as time passes, there are multiple different types of USBs coming out with faster data transmission rates. So studying a few of the drawbacks of the USB interface. So first of all, because USB is basically using some kind of cable, right? If you have a laptop, right, and you're sitting very close to it, you won't really have a lot of problem controlling the mouse, right? Because it has a sufficient amount of cable length. However, if you're sitting far away from a PC or something like that, you will have to face a problem due to the limited cable length, right? So if you have a keyboard or a mouse attached to your PC and you have to sit far away from it, you will have to face a little bit of a problem. Secondly, its speed limitations, right? Even though USBs these days are becoming very fast, chances are that in some use cases that may be not sufficient enough for you, right? In some use cases where you have to transfer a lot of data very quickly, you will still find USB to be very slow. Thirdly, its power limitations, right? So USB can supply power, however, the amount is limited, right? So in order to increase the amount, maybe you have to use another type of interface. Alright, so error detection. So if we were transmitting some data over a network, right, and some kind of error occurred, it will be very important to identify that error, because if that file is not the same as the file that was sent, right, this will occur in a lot of problems, right? And we have to make sure that we identify the error and we make sure that we fix that error as well. All right. So coming down to the methods for error detection, right? So the first method for error detection that we have to study today is called a parity check. The first type of parity check that we have to study today is called the odd parity check. All right. So let's just take an example. All right, I'll explain it to you with the example. So let's just suppose that we have to transmit this data byte, right? 1010 1010. Let's just suppose that we have to transmit this. So what we will do is basically we will just count the number of ones in it, right? So if we are using odd parity check, right, the parity bit, all right, this is very important. The parity bit will be set to 1, all right? So over here you can see that if the number of ones is even, add a parity bit of 1. If the number of ones is odd, add a parity bit of 0. All right. So over here you can see that 1 2 3 4, we only have 4 ones, therefore it is even, hence we add 1 parity bit. All right. So what we have to do is basically just send this parity bit along with this data, right? And then when this data is received on the other end, it does another parity check, right? It counts the number of ones again, and then it calculates the parity bit. Then it will check the parity bit again with the one that it calculated when it was received, right? So the one that was sent and the one that is calculated when the data is received, both of them are compared, and if they are the same, this means that there is no error. But if they're not the same, this means that an error occurred. All right. So over here you can see that we have another kind of parity check, which is called the even parity check, right? So this is the same as the odd parity check. However, there is one small difference. Rather than having 1 as the parity bit when the number of ones is even, it will have 0 as the parity bit. All right. So it will use 0 as the parity bit when it is using even parity check. All right. And when it is using odd, it will use 1. All right. So this is a small difference between the odd parity check and the even parity check. Other than that, they're both the same. All right. So coming down to the other example of parity byte. Right? So parity byte is basically the same thing that I explained before, right? So all this does is basically just it divides the data into bytes, and then it assigns a parity bit to match the parity, right? And this is just another example of one of the error detection methods. And next up we have a parity block, right? So rather than dividing the data into bytes, this error checking method will basically divide the data into blocks, right? This depends on the type of algorithm that is used to create this type of parity check. Alright, so coming down to checksums. So as I explained this to you before as well, that one of the commonly used types of error detection method that the data packet includes is called a checksum, right? So over here you can see that we will now study checksum. So checksum is very easy to understand, right? So a checksum basically involves summing the binary values of the data blocks and sending this sum along with the data, right? The receiver will then recalculate the sum of the received data blocks and compare it to the transmitted checksum, right? If there is any discrepancy, an error is detected. So this is also one of the ways that error is detected. Alright, so echo check is basically when the sender transmits the data to the receiver, right? And then the receiver immediately sends the data back to the sender. And then the sender will basically compare both the data that it sent and received. And if the data is the same, this means that no error occurred when it was transmitting the data. Alright. However, this is a very inefficient data method because you are basically sending the same data twice. So it is not very efficient. Alright, coming down to check digits. Alright, so now let's study about check digits. So a check digit is basically an additional digit calculated from the other digits in the number, right? This digit helps verify the accuracy on the number, right? Alright, so one of the examples of check digit usage is in ISBN, right? So if you've ever bought a book, you can see that behind it, it has an international standard book number, right? So these are basically of two types, right? ISBN 10 and ISBN 13, right? So the ISBN 10 is basically comprising of 9 digits and 1 check digit, whereas the ISBN 13 comprises of 12 digits and 1 check digit. Alright, so over here you can see that we've been given an ISBN 13, right? So in order to calculate the check digit for ISBN 13, we have to multiply each digit by 1 or 3 alternatively, right? So over here you can see that 9 is being multiplied by 1, and then 7 by 3, 8 by 1, 0 by 3, so on and so forth until we get the check digit, right? So when we calculate the sum, you don't actually need to remember this process, right? This is just for an example. You take the mod, right, the remainder of the division by 10, which is 3, and then we minus 3 from 10 and we get the check digit 7, right? So this is an example of how check digits work. You don't need to actually remember this process. Alright, so another one of the examples of check digit usage is in barcodes. So if you have ever been to a supermarket, right, you can see that it has barcodes behind every single product that it have, right? Almost every single product. And this is done so that you can accurately check what type of product it is when you are scanning that at the checkout counter, right? So one of the most used types of barcodes are called the universal product code, right? So it comprises of 11 digits plus a check digit, right? So this also has the process explained over here. However, you do not need to remember the exact process, right? This is just for an example. Alright, so now coming down to the last error checking technique, which is the automatic repeat query, right? So this is also very interesting, so listen carefully. So ARQ basically involves the use of acknowledgements and timeouts, right? So when the receiver detects an error, it sends a negative acknowledgement to the sender, which will basically be a signal for the sender to send the data again. Alright. However, if the positive acknowledgement is sent, this will basically mean that the data received is correct. So, for example, in a simple ARQ system, right, the sender transmits a data packet, all right. The receiver checks the data for errors, right, and if an error is found, the receiver will basically send a negative acknowledgement, right, and the sender will retransmit the data packet. If the data is correct, the receiver will send in positive acknowledgement, right, and that positive acknowledgement basically means that the data that was sent is correct, right. Another thing that is used in ARQ is basically called timeout. All right. So timeout is very crucial, right? So over here you can see that, for instance, if you're transmitting data, right, if the acknowledgement is not received within a specific time, the sender will assume that the packet was lost or corrupted, right, and he will retransmit it. This is basically just a way to ensure reliable communication. Alright, so in summary, all you need to know is that these are basically the few error detection methods that you need to know about, right? And make sure that you remember how each of them works, even though they are very similar and they have a lot of detail, right? These are not very difficult to remember, right? Because sometimes most of them have a lot of the information given in the name, right? So you don't need to know a lot of stuff about them. However, you should know how each of them works, right? Alright, so encryption is basically when we change the readable data that we are sending into an unreadable format, right? So if a hacker is basically getting its hands on data that I am transmitting to another person, right, he will still not be able to understand it, because in order to decrypt it, he will require a decryption key, right? And that key, or in order to actually convert that unreadable data into readable data, he will need some kind of key or algorithm that only I and the receiver has, right? So this will basically make sure that even if a third party does get its hands on the data, he will not be able to understand it, all right? And another few of the reasons are given over here as well. So I recommend that you remember at least 3 of them. Alright, so coming down to the purpose of encryption in data transmission. Alright, so over here, first of all, as I said before as well, that we make sure that even if a third person gets the data, he is not able to understand it, right? It also helps in preventing data breaches, right? So if we store the data on a server with encryption, right, this will make sure that even if a hacker gets access to a server, he will not be able to understand it, because in order to understand the data that is stored in the server, he will still require a decryption key, right? And only the people who are controlling that server or who need to use that server have that kind of power, right? So that is basically one of the purposes of encryption in data transmission. Anyways, coming down to the actual stuff that we need to know, right? So first of all, what you need to know is that there are two types of encryptions, right? Symmetric encryption and asymmetric encryption, right? So let's just study its process, right? So first of all, the sender will use an encryption algorithm, right, and a secret key to convert the plain text into ciphertext, right? The plain text is the readable data and the ciphertext is the unreadable data. Next, it will transmit the data over the network, all right, the ciphertext, right, the data that was encrypted over the network, and then the recipient or the receiver will basically use the same secret key that the sender used, right? So the sender and the receiver will have the same key beforehand, all right, and that key will basically be used by the recipient to convert the ciphertext back into plain text, all right. So this is a small example of how symmetric encryption works, right? First of all, what you need to know is that symmetric encryption is basically faster and more efficient for large data volumes, right? Secondly, it is simpler and less computationally intensive, right? So next up we will study asymmetric encryption, right? You will see that it is basically more intensive and it requires a lot more calculations and stuff like that. And because symmetric encryption requires less processing than asymmetric encryption, symmetric encryption is basically faster and requires less computational power, right? However, it does have a few disadvantages. For example, that if the key is compromised, right, that the sender and receiver are using, the encrypted data will be compromised, right? The security of the encrypted data will be compromised. Now we will study asymmetric encryption, which is the last topic we will be studying today. So first of all, what you need to know is that each user basically generates a public key and a private key. Alright, so there are two keys used over here. So in symmetric encryption, we were using one key, right? That both the receiver and the sender had. However, over here we will be using two different types of keys, which is called the public key and the private key. Alright, so the public key is basically shared with others. However, the private key is kept secret, right? So first of all, the sender encrypts the plain text using the recipient's public key. Alright, the encrypted message is sent to the recipient, and then the recipient uses their private key to decrypt the ciphertext back into plain text. However, what you need to know is that only the recipient's private key can decrypt the data encrypted with their public key, right? So this is one of the small differences between symmetric and asymmetric encryptions. So over here you can see that I've given another example, right? So if Alice wants to send a secret message to Bob, Alice will use Bob's public key to encrypt the message, and then Bob will use his private key to decrypt the message and read it, right? This ensures that there is another layer that the hacker will have to go through to ensure that he is able to read the encrypted data. A few of its advantages are that you don't need to share the secret key beforehand, right? Because that will already be shared. And then secondly, enhanced security, right? Since the private key is actually never shared. However, it will have a few of its disadvantages, as I told you before as well. Is that first of all, it is computationally more intensive, and secondly, it will require more processing power, right? And it will also be slower. Alright, so I hope that you like this video. Make sure to like my videos and subscribe to my channel, and I will be uploading more videos more often. Also make sure that you share these with your other friends who are studying the same subject. Alright, I'll see you later.